Hello dear students, welcome back. This is the fourth lecture on the topic set. In this class, we are going to study subsets, equal sets and power of a set. Before I begin with equal sets, let me tell you one important note. All infinite sets, infinite means uncountable, all infinite sets cannot be described in the roster form. This is a very important note. You can keep it in mind. Now, let me begin with equal sets. How to define equal sets? Let me start with the definition. Two sets, capital A and B, are said to be equal if they have exactly the same elements, and we write A is equal to B. Dear students, if A and B have the same number and same elements, same number of elements and same objects, such sets are called equal sets. Otherwise, sets are said to be unequal, and we write A is not equal to B. If the elements of both the sets are different, then both the sets are not equal, and we write this as A is not equal to B. For example, A is equal to a set containing two elements 2, 3. This type of form is called a roster form. There is one more set B which is equal to a set containing x such that x is a solution of x square minus 5 is equal to 0. This type of form is called a set builder form. Let me represent the set builder form in a roster form. Let me solve this equation x square minus 5x plus 6 is equal to 0. This is an algebraic equation of second order. We know the factors of this equation. The factors of this equation are x minus 2 into x minus 3, which is equal to 0. Therefore, the values of x in this sets are 2 and 3. If we compare A and B, they have the same number of elements. Therefore, in this case, we can say that A is equal to B. Therefore, this is one of the important questions or example to show that both the sets are equal. Let me begin with the another example. A is equal to singleton set containing 0. 0 is an element. B is a set containing x such that x is greater than 15 and x is less than 5. Dear students, this type of form is called set builder form. We are going to represent this into the roster form. There is a number which is greater than 15 and less than 5. There is no such number which is greater than 15 and less than 5. Therefore, this type of set is called as an empty set. Therefore, A is a set containing singleton element 0. 0 is an object, element, member of the set A. But there is no such element which is greater than 15 and less than 5. Therefore, this set is an empty set. There is no element in this set. Therefore, empty set will be denoted by the notation 5 or empty brackets. In this case, there is only one element which is not there in the set B. Therefore, we can say that A is not equal to B. Therefore, this is an example of unequal set. Dear students, let me begin with the one more question, that is one more example. Example number 3. A is a set containing the elements B, C and D. B is another set containing the elements D, C, B and A. If you observe the two sets, the elements of both the sets are same, but they are different in order. As I told you in the beginning in the first class, the elements can be written in a different order. In the representing the sets, the order is not important. The number of elements of both the elements are same and same objects are given. Therefore, such sets are called equal sets. Therefore, in this case, we can say that A is equal to B. Now, one more important concept. Today we are going to study subsets. What do you mean by subsets? We know the sets, their definition, notation, methods, and finite set, infinite sets, etc. Now, today we are going to study subsets. Definition. A set capital A is said to be subset of a set B if every element of set A is also an element of set B. And we represent this as A is a subset of B. Symbolically, we write this set as A is a subset of B. This is the symbol represents the subset. All the members of A are there in set B. Such sets are called subset of a given set B. In other words, we can write A is a subset of B if every element of A is a member of B. And then we write the definition as follows. A is a subset of B. If A belongs to A, then A is also belongs to B. Then such sets are called subset of a given set B. We read the above statement as A is a subset of B. If A is an element of A, capital A, implies that A is also an element of a capital set B. Dear students, if A is not a subset of B, then we write A is not a subset of B. Here, if A is not a subset of B, then we represent not a subset of B as A is not a subset of B. Means any one of the element, one or more elements are not there in a set B. In such case, we can say that A is not a subset of B. Dear students, here you understood that the meaning of subset. All the members of one set are there in the another set or a given set. Such sets are called subset of a given set. For example, suppose if A is a set containing the elements like A is equal to, the elements are A, B, C, and another set B is equal to containing the elements B, C. Then in this case we can say that B is a subset of A, but A is not a subset of B because all the members of B are there in A, but all the members of A are not there in B. Then we can say that A is a subset of B, but A is not a subset of B is a subset of A, but A is not a subset of B. The students, let me write one note. Every set is a set of itself. Any set has its own subset. Therefore, we can rewrite this as A is a subset of itself. A is a subset of A. The second important note is, since the empty set has no elements, we agree to say that empty set is a subset of every set. Dear students, remember that empty set is a subset of any set. And then we write that is also a subset of any given set. Third important note is, let A and B be two sets. If A is a subset of B and A is not equal to B, meaning is the members of both the sets are unequal, but A is a subset of B, then A is called a proper subset of B and B is called as a superset of A. Like in the previous example I gave, A is a set containing the elements A, B, C. B is a set containing the elements B, C. Then B is a subset of A and both are not same. Therefore, A is called as a superset of B. Dear students, let me take one example. Write the subset of the following set. Dear students, one set is given for us. A is equal to the set containing the elements 1, 2, 3. We have to write all possible subsets of a given set A. As per the note, as I just now told you, empty set is always a subset of any given set. Therefore, 5 is a subset of any given set. Therefore, this is one subset of a given set A. Singleton 1 is also a subset of A because 1 is a set which contains from set A. 1 is there in the set A, therefore this set is called as a subset of A. Singleton 2 is also a subset of A. Singleton 3 is also a subset of A. 1 and 2 is a subset of A. 2, 3 is a subset of A. And 1, 3 is also a subset of A. And 1, 2, 3 is also a subset of A. As per the note 1, every set is a subset of itself. Therefore, all the elements of the given set is also a subset of a given set. Therefore, in this problem, we have the subsets. The number of subsets are 1, 2, 3, 4, 5, 6, 7, 8. The element A has 3 elements, and the subset of any set is given by the formula 2 raised to n, where n is the total number of elements of a given set. Therefore, 2 raised to 3 is nothing but 8. Therefore, A has 8 number of subsets. Likewise, we can find the subsets of a given set B. Since B has 2 elements, therefore the total number of elements of this sets are, the total number of subsets of a given set B are 4, 2 raised to 2. Therefore, the elements of this set B are, subsets are 5, singleton A, singleton B, and A, B. Therefore, these are the subsets of a given set B. Dear students, in this case also we are going to learn intervals as subsets of R. R is a set of real numbers. Dear students, you know the set of real number on the number line we can represent like this. This is the middle number 0, plus 1, plus 2, plus 3, and so on. This side we have minus 1, minus 2, minus 3. This is a number system line. Now in this case, if I take any 2 elements, let A and B be any 2 elements belongs to R, and A is less than B, then we can define the open interval. Let A and B be belongs to R and A is less than B. Then we have the open interval X. It is also a set containing X such that A is less than X less than B is called an open interval and denoted by the small bracket A, B. In this case, the element A is and B are not belongs to the open interval. Meaning is, in the open interval, A and B are not inclusive. These boundary elements are excluded in the given problem. For example, suppose the set contains 2 less than x greater than x, that is 2 less than x less than 4. The elements which are lies between 2 and 4 are the only members of the open interval set. This symbol represents an open interval. We represent sometimes by the small brackets. We can write like this: 2, 4. The elements between 2 and 4 are the only members of the given set. This type of form is called as a set builder form, and the same representation we can write the bracket A, B called as a roster form. The elements of these sets are only like and 4. Then the infinitely many numbers lies between 2 and 4. Excluding 2 and 4, all the members of the sets are belongs to the given set. Therefore, such interval is an open interval. Moving to the next type, we have the another type, that is closed interval. Closed interval X such that A is less than or equal to X and less than or equal to B is called the closed interval, and it is represented in the square box. The elements in this sets are A, B. Such set is called the closest set. In this case, A and B, both the boundary values are the part of the set. Both are belongs to the given set. Both are inclusive. In the open interval, A and B are exclusive. In the closed interval, A and B are also inclusive. For example, the closed interval 2, 4, we can write the elements of the sets are, it is 2, 3, 4, etc. In the open interval 2, 4, we can write only the element 3. Only element 3 we can write. because 2 and 4 are not inclusive in the open interval, but 2 and 4 are inclusive in the closed interval. Therefore, such type of form is called as an closed interval, and this type of form is called an open interval. Moving to the next type, half open, half closed. Dear students, there is a set containing x such that a is less than or equal to x less than b is called left closed and right open. Meaning is left side it is closed and right side it is open. Means a is inclusive but b is not inclusive. Therefore, such type of interval will be called as an left closed, right open. For example, suppose if I write left closed, right open. In this case, the set elements of the sets are 2, 3. Here 4 is not inclusive because of the open interval, but 2 is inclusive, therefore because of the closed interval. Therefore, the elements of these sets are 2, 3. Similarly, we have the one more type called half open, half closed, that is left open, right close. Suppose if I take the elements like 2, 4, it is left side it is open, therefore 2 is not inclusive. The elements in this sets are 3, 4. 4 is inclusive because to the right side it is closed. Therefore, such type of form is called half open and half closed. Subset of a set of real numbers. Some of the relationship among these sets or subsets are given by. Now, set of natural number is obviously a subset of whole numbers. Whole number is a subset of integers. Integer is a subset of rational numbers, and rational numbers are subsets of what are real number. Set of real number is a superset of all the above sets. Now, n is a set containing the elements. N is a set containing the elements only 1, 2, 3 and so on. W is a set containing the elements 0. 0 is the extra element in this set. 1, 2, 3 and so on. In this case, we can find that n is a subset of W. But W is not a subset of what are n, because 0 is not a member of the set n. Therefore, W is not a subset of n. All the elements of n are there in the set W. Therefore, we can say that n is a subset of W. Dear student, this is an important question for 1 mark. They may ask define power set or write all the power set of a given set, which will be asked in the examination for 1 mark. The collection of all the subset of a set A is called power set. The group of all the subsets of a given set A is called a power set of A, and it is denoted by P of A. P stands for power of a given set A. For example, A is a set containing 1, 2. Then we write all the possible subsets of a given set. That is called power set. A is a set containing the elements A, 1, 2. Now let me write the subsets of a given set. Therefore, empty set is a subset of a given set. Singleton 1 is also a subset of a given set. Singleton 2 is also a subset of a given set. And the elements which are containing 2 elements 1, 2. These are the subsets of a given set A. Therefore, the group of all the elements of these subsets is called power of a set A, and we denote it by the symbol P of A. Therefore, power of a set is nothing but each element of a power set is in the form of a set. Therefore, the group of subsets of a given set are called power set. My dear students, we have an example over here. A is a set containing the elements like empty set, singleton 1, singleton 2, and then the set containing the elements 1, 2. Therefore, these are the members. The group of all the subsets of a given set. The group of all the subsets of a given set is called power set. Note that the number of P of A, n of P of A, is always equals to 4. That is, how many elements are there in the set A? 2 elements. You have to raise the power by 2 because empty set and set itself are the subset of a given set. That's why the number of elements of a given set to the power 2, that gives the total number of subsets of a given set, and the group of all the subsets of a given set is called as the power set. With this, I conclude my today's class. I hope you have understood all the concepts. If you have any queries, please contact the given below number, or you can WhatsApp. Thank you. Stay home, stay safe.